hours writing the perfect automation script, executing it flawlessly, only to hit a wall. A Cloudflare Turnstile loop or an endless reCAPTCHA test stops your scraper cold. When this happens, most developers reach for the standard toolkit, plugins like Playwright Stealth or undetected Chrome driver. But those tools share a mechanical flaw. They rely entirely on JavaScript injections, placing a thin, cosmetic mask over bot behavior. Modern anti-bot systems actively scan for these surface-level patches. The moment Chrome updates, the scanner flags the discrepancy, breaking the scraper. Treating bot detection as a cosmetic problem is a dead end. Staying undetected requires moving past the browser's interface and modifying its core source code. CloakBrowser solves this by abandoning JavaScript injections entirely. It operates as a complete structural replacement. Instead of hiding fingerprints later, the engineering team apply 49 specific patches directly into Chromium's raw C++ codebase before compilation. These natively rewrite how the browser reports hardware signatures. WebGL and Canvas rendering data are hard-coded to spoof legitimate user metrics at the source. The codebase also alters audio contexts and system hardware reporting at the lowest possible system layer. The result is measurable. In live testing, the browser achieves a server-verified 0.9 trust score on reCAPTCHA v3, a metric reserved for high-reputation human users. It also passes Cloudflare Turnstile entirely, seamlessly resolving both managed and non-interactive challenges without triggering any secondary flags. Anti-bot systems categorize CloakBrowser as a legitimate human user because structurally it is a real browser. Having a perfect hardware profile is useless if your automation interacts with the page using robotic, instantaneous precision. To fix this, CloakBrowser introduces a single flag, Humanize equals true. Enabling this one setting rewires how the Playwright and Puppeteer input APIs function. Standard bots move the mouse in rigid, linear paths. The Humanize engine simulates natural human movement by calculating smooth Bezier curves, intentionally overshooting the target slightly before correcting back. It applies the same logic to keyboard inputs. The system mimics actual typing speeds, introduces micropauses, and makes occasional typos that it instantly self-corrects. Maintaining a high trust core depends on this specific logic, building a precision system that can accurately recreate human mistakes. The final layer of bot detection targets network context and session history. Many security tools hunt for suspicious, ephemeral sessions. CloakBrowser's persistent contexts feature keeps cookies and local storage active across runs, bypassing systems that penalize empty incognito profiles. But the ultimate defense secures the most common data leak in proxy setups, WebRTC IP spoofing. This system automatically extracts and matches your proxy's exact exit IP during the handshake, without relying on slow external network calls to check your location. Elite stealth is only achieved when the source architecture, the interactive behavior, and the network identity perfectly align into a single cohesive profile. Superficial script-level patches can no longer outpace modern behavioral analysis. Robust automation now depends on integrating stealth at the binary level. If this saved you time, hit subscribe. We review tools like this every week so you're always ahead. Now, if you liked CloakBrowser, you're going to love our breakdown of Crawl for AI. Bot detection will always be an arms race, but with source-level stealth, the advantage just shifted back to the builders. Keep experimenting, keep automating, and